My lab at Carnegie Mellon is really focused on understanding how we can rebuild human tissue. And to do that, we really need to understand how we can combine cells and things like collagen, basically the extracellular matrix used in the human body, and combine them in such a way that we can recreate tissue and ultimately organs.
I think this project is a wonderful melding of the expertise of both sides of the coin. So on the Mayo Clinic side, I bring forward questions and concerns I have clinically. I share those with my CMU colleagues and partners. Dr. Feinberg and his team bring back the engineering solutions and suggestions. And so it's really a dynamic exchange, a back and forth between each different team member. Our goal is to find new ways to better use the organs that we have and potentially to develop new organs or new sources of organs that would allow us to transplant more patients and more people in need.
We can take a 3D object, take that medical imaging data directly into the computer program, design a patient-specific tissue construct, and then feed that directly to the bioprinter, which now starts to build it up layer by layer by layer. My laboratory at Carnegie Mellon developed this really cool technology where we basically 3D print inside of a material like hair gel. And that allows us to really support and control the tissue as we're building it, and then we melt away that support and leaves behind the bioprinted tissue.
The idea of a booster liver in particular is what we're looking at with this project. A booster liver is a liver that really augments the function of what you already have. So our idea is that we can use this booster liver to supplement or to support that native liver until that liver recovers and comes back to its normal function. And instead of being subjected to a lifetime of immunosuppression, you can go back to sort of a normal quality of life as well.
I think transforming transplant is just an incredibly exciting initiative because, we have, I think, the technologies that we need today already to actually build human tissue. What we don't know is how to do it. And now it's all about bringing the right group of people together to actually create the organ. And having the clinicians and the engineers working together really allows us to maximize the different kinds of technologies we can bring together on the engineering and science side, but really tie that into a focused application on the clinical side and really addressing the key problems the physician is facing. And transforming transplant, in my mind, is really a way to really accelerate that process.